So today we're going to look at 5.4, which we started talking about last time. And so we're talking about matrices. And so let's say our typical matrix is A, B, C, D. And we're going to find its inverse. So for a 2 by 2 matrix, its inverse, we said, looked like, we've got 1 over, we multiply these two pieces, so A and D. We're going to subtract and multiply these two pieces, so B and C. Then we're going to switch these two and then switch the signs on these, so make those negative. If they're already negative, we'll make them positive. Okay, so we said that if we had a matrix A and we multiply it by its inverse, that's going to give me my identity. So it's going to look like 0, 1, 0, 0, 1. Okay, and it could go either way. So I could switch these around because typically we said that we cannot switch the order of our matrices and get the same answer, but with the identity, with inverses, we actually can. So they give us the exact same thing. So let's find our inverse for a function. So say I have 6, 5, 5, 4. Okay, so we'll call this A. So we want to find our inverse. So the first thing I do is we multiply here. So it's going to give me 24. Multiply here. It's going to give me 25, and we're going to subtract them. Now in here, we're going to switch these two. So it's going to be a 4, going to be a 6, and then make these negative. So it's negative 5, negative 5. Now 24 minus 25 is just negative 1. So I have 1 over negative 1, so it's just negative 1, 4, negative 5, 6. So we just distribute that negative, and my inverse is going to be negative 4, 5, 5, negative 6. All right, so let's check and make sure that we did it right. So if we did it right, I can multiply these two together. So we said 6, 5, 5, 4, and multiply negative 4, 5, 5, negative 6. Oops, let me slide that up, we can see it. And that should give me my identity. That's 1, 0, 0, 1. Okay, so we're going to multiply this row by this column. So I've got 6 times negative 4 is negative 24. 5 times 5 is 25, so negative 24 plus 25 is 1. So here's going to give me 30. This is going to give me negative 30, so it's a 0. Here it's going to give me negative 20, positive 20, so it's a 0. And then 25 minus 24 is 1. So let's go ahead and just switch that order for us. So it's negative 4, 5, 5, negative 6. And just show that they do give us the same thing. Okay. So let's do the same thing. So it's 4 times 6 is 24, negative 24. 5 times 5 is 25. So negative 24 plus 25 is 1. Then I've got 24 times 5, that's 20. Plus 20 is 0. Or negative 20 plus 20 is 0. And then next I've got 30. So I've got this row times this column, so it's 30. That's negative 30 is 0. 25 minus 24 is 1. So they do. So they both work. Now, this only works for this rule up here. Only works for a 2 by 2 matrix. If you get bigger than that, we have to have a square matrix to find an inverse. If you have like 2 by 3 or 5 by 7 or whatever you want, it's not. We can't find an inverse to it. So it has to be square. So it's 2 by 2, 3 by 3, 4 by 4. Now we also, for anything bigger than that, what we're going to use is our Gauss-Jordan method, which is what we did in 6.1 and 6.2, which I know you'll love so very much. I'm being sarcastic. So let's do that. So what we're going to do is we're going to set it up. So say I have my matrix. So I've got 1, 2, negative 1. 1, 2, negative 1. I'll just put a line there. Negative 2, 0, 1. 1, negative 1, 0. And on the other side of this line, I'm going to put my identity matrix. So what we're going to do is use the same operations we used in 6.1 and 6.2, and we're basically going to switch these. We want to make this look like my identity, and then whatever we get over here is the inverse to this. Okay, so let's do that. So we want to get a 1, 0, 0, so I've got a 1 there, so it's good. So I'm going to make this a 0 and make this a 0. So to make this one a 0, I'm going to multiply this top row by 2 and add it. So I'm going to say 2 times row 1 and add it to row 2. Okay, now to get this one to be a 0, I'm just going to multiply this top row by negative. So I'm going to say negative row 1 plus row 3. Okay, so I'm going to do that to everything, all the way across. So we're going to leave the first row alone. Now I'm going to multiply this row by, we said to give me a 2. So multiply this by 2 and add it here. That's going to give me a 0. Multiply this one by 2, it's going to give me a 4. Add it. That's going to give me negative 2 plus 1. So negative 2 plus 1 is a negative 1. So I'm going to do the same thing here. So 2 plus 0 is 2. 0 plus 1, 0 plus 0. All right. So now we're going to do the same thing. So multiply this top row by negative and add it here. So that's going to give me a 0. Top row by negative, so it's negative 2 plus a negative 1 is negative 3. Top row by negative, so that's a positive 1 plus 0 is a 1. Now top row by negative, so it's negative 1 plus a 0. And then these are not going to change. So that's 0, and that's going to give me a 1. Because 0 plus 0 is 0. 0 plus 1 is 1. Okay, so now we want to get a 1 in this middle piece. So I'm going to divide this by 4. Or we could add these two rows, add this one to this one, and that'd give me a 1 as well. So I'm going to say row 3 plus row 2. I'm trying to avoid fractions. I'm going to leave the first row alone. And we're really leaving the last row alone too. Okay, so all we're going to do is add these two rows together to make this a 1. So if I add these two, that's going to give me 0, 1. That's going to give me a 0, so that works out nice. Add these two, that's going to give me a 1. It's going to give me a 1, and that's going to give me a 1. Okay, so we just added those two rows together. So now I want to make this one a 0 and make this one a 0. So if I'm going to make this one a 0, I'm going to multiply this one by negative 2. So negative 2 times row 2 plus row 1. Okay, so that's going to give me a 0 here. To get a 0 here, I can multiply this row by 3 and add it. So 3 times row 2 plus row 3. So let's do that. So we're not changing our middle row. 1, 1, 1. Okay, so now let's look at it. So we're multiplying this one by negative 2. That's not going to change. This one by negative 2, so that's going to give me a 0. This one's not going to change. And then multiply this by negative 2. Negative 2 plus, that's going to give me a negative 1. This is going to give me a negative 2. And this one's going to give me a negative 2. Okay. So down here, I'm going to multiply this row by 3 and add it. So it's going to give me a 0, a 0. That's going to give me a 3. Add it, it's going to give me 1. Well, 3 times 0 is just 0, so it's still going to give me a 1. So that works out nice. So down here, I'm multiplying this row by 3, so it's a 3. So it's plus a negative 1 is 2. 3 plus 0 is 3. 3 plus 1 is 4. Okay. And so now the only thing left is we need to get a 0 there. So if I just add these two rows, so I'm going to take row 3 and add it to row 1. So leave row 3 alone. Leave row 2 alone. And then here row 1. The first two, if I'm adding, it's not going to change. Just let that in. So a 1 plus a negative 1 is 0. 2 plus a negative 1 is 1. 3 plus a negative 2 is 1. 4 plus a negative 2 is 2. So this would be our inverse. So we've got matrix A, we'll call it matrix A. Come back up here. We said it was this matrix. So 1, 2, negative 1, negative 2, 0, 1, 1, negative 1, 0. So its inverse now is this matrix. 1, 1, 2, 1, 1, 1, 2, 3, 4. Okay? So that's how we would find our inverse for any size matrix. There's not just a nice set rule that's easy. There is a couple rules for a 3x3, but this is definitely easier than trying to follow that rule. So this is what we're going to do for a 3x3. We can also, using matrices, we can solve linear equations a different way. So you didn't like Gauss-Jordan method. At least that's what you told me. So what we can do, let's see. So we've got a 6x plus 5y equals 13. And I've got a 5x plus 4y equals 10. So we can actually put this in a matrix and solve it. So I'm going to put this in a matrix. I'm going to put my coefficients. So it's got 6, 5, 5, 4. And then so I put my x, y in here. And then I've got 13, 10. The reason we can do this is say I multiply these two together. So I've got 6 times x. So let's see, I multiply this. So I multiply this row by this column. So I've got 6x plus 5y equals 13. Okay, so I get back where I started and do the same thing with this row. So I've got 5x, 5 times x, plus 4 times y equals 10. So I get this exact same thing. So if I'm looking at these rules, so I've got matrix A times matrix X equals, we'll call this matrix B. See, if I want to get this X by itself, so we want to solve for this, what we need to do is get rid of this A. We can't divide by matrices, but our identity matrix is basically like multiplying by 1. If I take that identity and multiply by any matrix, I get that same matrix again. So what I could do is multiply by my inverse on both sides. And we have to do it on the same side because matrices are not commutative. This is going to give me my identity matrix. And so basically this is like a 1. So it'd be x equals A inverse times B. Okay? So we're going to find the inverse and then multiply it by B. So if we look at this, we actually found this one a minute ago. So 6, 5, 5, 4 is A. So we need to find A inverse. So we'll do it again. So we said 6 times 4 is 24. So it's 1 over 24 minus 5 times 5 is 25. Then we're going to switch these two and make these two negative. So just kind of refreshing our memory. So this was a negative 1. So 1 over negative 1 is negative 1. So now we can distribute our negative 1. So negative 4, 5, 5, negative 6. All right. So now to solve this piece up here, we can rewrite it. So we had 6, 5, 5, 4, x, y equals 13, 10. So what I'm going to do is multiply both sides of this by this equation. I'm going to write it out. So I'm going to have negative 4, 5, 5, negative 6, 6. So I've got 6, 5, 5, 4, x, y, and then here I've got negative 4, 5, 5, negative 6, 13, 10. Okay, so let's multiply these two. So just to kind of check ourselves. So this row times this column. So I've got 24, negative 24 plus 25 is 1. And then negative 20 plus 20 is 0. 30 minus 30 is 0. And then 25 minus 24 is 1. So I've got this. And let's multiply these. So negative 4 times 13 is, what is that going to be? Negative 4 times 13 is 52. So negative 52 plus 5 times 10 is 50. So it's going to give me a negative 2. And then 5 times 13 is going to give me 65. Minus 60 is going to give me a 5. Okay? So my answer is negative 2, 5. So let's go up here and check ourselves. Make sure. So we said x is negative 2, y is 5. So let's just check it. So if I plug in a negative 2 here, it'll give me negative 12 plus 25 is 13. So that one works. Excuse me. So if I plug it in here, so 5 times negative 2 is negative 10. 5 times 20, so sorry, 5 times 4 is 20. That gives me a 10. So they both work. Okay? So let's do another one like that. Let me find another one that'll be pretty. Okay. Say I have so I've got 7x plus 5y equals 13. Then I've got 3x plus 2y equals 10. So we're going to do the exact same thing. So I'm going to set this up. So I've got a matrix. I've got 7, 3, 5, 2, x, y equals 13, 10. No, that should be 23. Yeah, I looked at it again. I was like, really? Both of those are the same. So 23, 10. Okay. Next slide over you can see. So the first thing we're going to do is find the inverse to this. So my inverse, so we're going to multiply here. So it's 14. So I've got 1 over 14 minus multiply here. That's 15. And then we're going to switch these two and make these two negative. Okay, so again, this is negative 1, so it doesn't always work out that nice, but in this case it did. So you're going to get negative 2, 5, 3, negative 7. Okay, so to solve this, I'm going to multiply both sides by that. So I've got negative 2, 5, positive 3, and negative 7. So 7, 5, 3, 2 times xy equals my inverse times 23, 10. Okay. So let's multiply these. So let's go ahead and multiply this just to check ourselves to make sure we didn't do something wrong. This one give me 14, negative 14 plus 15, that's a 1. And this row, so it's negative 10 plus 10 is 0. Here I've got 21 minus 21 is 0. That's 15 minus 14 is 1. So it does work. So over here, we're going to look and say negative 2 times 23 is negative 46 plus 50. So what is negative 26 plus 50? Is that 24? And then here, so 3 times 23 is going to give me 69 minus 70 and give me negative 1. Okay? I think I messed up this first one. What is this? So I've got negative 2 times 23. That's negative 46. Yeah, so negative 46 plus 50 is just 4. I was thinking 24 looks really big. That's what happens when I'm doing this late at night. So I've got negative 46, 50. Okay, so let's just check our answers real quick. So I slide back up. So I'm going to rewrite these down here. So 3x plus 2y equals 10. Okay, so let's plug these in. So 7 times 4 is 28, plus a negative 5, that is 23, so that works. If I check the other one, 3 times 4 is 12, plus 2 times a negative 1, that's going to give me 10. So they both work. Okay, so the other thing we can do is coding and decoding. Okay, so if I'm going to code something, we're going to multiply a message. Let me grab another pen. Multiply a message by a matrix. So if we multiply a message by a matrix, I can code it. So if you think about like your credit cards, or when you put your credit card numbers in the computer, you don't want anybody to see that. So but basically what the companies do is they code it, it sends it through the web, and then the company has a decoding device to decode it. And so with matrices, a lot of times they use matrices, or they use algorithms or something to code and decode. So to code it, we're going to have a coding matrix. The decoding matrix is actually the inverse. So say I have a message. Say we want to, we're going to say let A correspond with 1, and B correspond with 2, and C correspond with 3, and so forth and so on. Okay. The other thing is we probably wouldn't set it up to be this easy. Okay, and so say we want to send the message A, B, C, D. Okay, now again, that would be kind of easy. But what we're going to do is I'm going to set up a matrix. So this is 1, 2, 3, 4 for my code. And I'm going to multiply that by a matrix